Hello, and welcome to today's daily Leetcode challenge. Today we'll be solving question 2265, count nodes equal to average of subtree. Count nodes equal to average of subtree. Okay, so given a root of a binary tree, return the number of nodes where the value of the node is equal to the average of the values in its subtree. Okay, so in my own words, doing DFS, or no, sorry, wait, before even ever doing DFS, what is an average of a subtree? It would be the sum of all the nodes in some subtree divided by the count. So, for example, for the value 8, it would be 9 divided by 3, so 3. If this value was equal to 3, okay, well then the average would have been different, but you get the point. If this value is equal to the value of sum of all of the subtree values divided by the count, then increase the count by 1, right? So for example, for this, if the sum of all the elements in the tree divided by 6 was equal to this number, then I would increase count by 1. Nice. Notes the average of n elements is the sum of n elements divided by n rounded down to the nearest integer. We can do that. I know how to do that. Subtree root is the tree consisting of root and its descendants. So yeah, another quick point, a sum of a subtree includes the node from which the subtree is formed. So for example, in a subtree starting from 4 would include 4 in it. And let's see some examples. This is the example, output 5. It means that 5 subtree averages are equal to the root of where the subtree starts from. And let's look at those numbers. The 4 apparently is 4 plus 8 plus 5. 0, 1, 6 divided by 6. 24 divided by 6 is 4. Counts. Same goes for the 5, apparently. The average of a subtree is 11 divided by 2. Oh, okay, so slight difference. If you were to count the average, it would be the rounded down to the nearest integer. So 11 divided by 2 is 5. That would make sense. 0 divided by 1 is 0. So this counts. Okay, so all the leaf nodes also count. So 1, 2, 3, 4, 5. Awesome. Oh, and they're highlighted in blue. All right. So how would I approach this? This seems like a recursive definition for what a subtree's this property is. Currently, I'm thinking that if I do DFS, deep first search, on a tree, I could recursively define what a subtree's average and size is, which would, well, actually no, sum and size, which would eventually produce the average. So this is definitely going to be a modification on DFS. Let's begin coding. I'll have the count here starting at 0, which is what I want. I want a DFS with some node, and I'm going to be returning, I said, I'm going to be returning the count, which is the size of the subtree, plus the sum, right? So if not node, then I want to return 0, 0, this tuple. Then I want to do, let's have this be the count and this be the sum. So subtree count, count left. sum left equals DFS on node left. Now I want the right and right. Awesome. I have the count for the left, count for the right. Now what would I, let's do subtree count is equal to left plus right, plus right plus current, because we're including the size of the subtree. We're including the root of the subtree in the count. Same goes for subtree sum, sum left plus sum right plus node val. Simply here, we now do the calculation. If node val is equal to, and let's do this, subtree sum divided by subtree count, then increase count by 1. Let's have this here, non-local count, and eventually simply return the, what do we say, count and sum, so subtree count and subtree sum. Then call DFS on root and return count. I think that this is it. Let's run quickly, see if there are any edge cases. Nope. All good. Yeah, very simple question if you notice the pattern right away, and also not a hard pattern to notice. So let's see how we did relative to others. Not so good. Interesting. Not using any defaults. Count. This Python. Oh, and these guys are doing, this is one-to-one self count. This is the exact same answer, pretty much. So that just leads me to think that this is another variation in the submissions. From submission to submission, Leetcode sometimes increases the runtime, but I mean, this one beats what? Yeah, this one beats most of the solutions. So actually, I mean, this is a perfectly okay solution. I would recommend you use this. Let's keep this video short once again. Thanks for watching, and I'll catch you tomorrow. Like and subscribe. Thank you. Bye.